So now let's solve some literal equations, which are equations that contain more than one variable. So here we are asked to solve r equals pq for p. So we want to get the p by itself, and the p is being multiplied by q. So to isolate the variable p, we simply need to remove that multiplication, so we divide both sides by q, and so then we would say that p is equal to r over q. And we can just turn that around, p is equal to r over q. Solve h is equal to 1/3 m square r for r. Well, we need to isolate the r, but we have that fractional coefficient. Now, we don't really like to have those fractions in there. We don't want to have to divide by a fraction, so let's multiply through by a common denominator. So I'm going to multiply both sides of the equation by 3. So then 3h is equal to, now the 3 and the 1/3, 3 times 1/3 is 1, 3 times 1/3 is 1, so m square r. We're still solving for r. Notice that the r is being multiplied by m squared, so we will divide by m squared. So then r is isolated and is equivalent to 3h over m squared, and just turning it around, r equals 3h over m squared. Solve d is equal to ax plus c for x. So what's happening to the variable that we're concerned about? We're concerned about x. It's being multiplied by a, and there's an addition of c. So if we sort of think of the order of operations, we would multiply first and then add. So to solve, we're going to undo them in the opposite of the order of operations. We will subtract the c first from both sides of the equation. Now d and c are not like terms, so we cannot combine them. So d minus c is equal to ax. Now we still have that multiplication, and so we will undo the multiplication through division by a on both sides. And so then x is equal to d minus c over a, and we can turn it around. X is equal to d minus c over a.